Hello everyone, today I'm back with another video. My name is Rakshita. I'm pursuing my final year degree from Sri Venkateswara College of Engineering from the Department of Electronics and Communication Engineering. Today in this video I'll be explaining about my internship, and my internship project is based on UNO design for line follower robot under the guidance of Professor Anne Gowda AB, Assistant Professor, Department of Electronics and Communication Engineering. So these are the contents I'll be discussing today in this video. I'll be discussing about the company profile and introduction to our project and objectives of our project and block diagram flow algorithm which I have been used in my project, and advantage and disadvantages, application, result and discussion, and conclusion. So now I'll be telling about my company profile. Mifra Tech Private Limited, which was established in 2016, is providing high quality priced products and services to the customer in embedded solution for the packaged products, product development, and in technology solution covering embedded system and system software and its global client. Mifra Tech OPC Private Limited was started by Abdul Nabi with an objective of providing an integrated system solution for any organization. Over the years, we have plunged into diverse domains, acquiring values insight into the business of product engineering. So this is about the company profile. Next, we'll be seeing introduction of our project, that is UNO based on line follower robot. The incredible combination of engineering and programming and electronics in robotics continues to advance to create smarter machines with greater performance. Line following robots are popular for their simplicity and effectiveness in navigation, making them an excellent starting point for beginners and enthusiastic alike. At its core, the UNO Arduino Life robot utilizes infrared sensors, that is IR sensors, to detect and follow a predefined path, typically on contrasting line on a surface. By integrating these sensors with the Arduino UNO microcontroller board, we can program the robot to autonomously navigate along the path, adjusting its direction based on the feedback received from the sensors. A couple of sensors, motor, and a chassis, the Arduino UNO transform into a capable of interpreting its surrounding and executing the commands accordingly. So now let's see about the objectives. The first objective is to design the robot to navigate the path as quickly as possible while maintaining precise line tracking. The second objective is to efficiently integrate IR sensor for, for line detection under varying lighting conditions. And the third objective is to extend the robot's functionality to avoid simple obstacles while adhering to the line following task. The fourth objective is to implement basic remote control features for manual operation and monitoring. And the last objective, that is fifth objective, is to enable the robot to make real-time adjustment in speed and direction based on immediate sensor feedback. Uh, this is my plan of work. We had been carried out the internship for the 1 month, and these are the activities done in the each individual day. Next are the components required for UNO line follower robot. First one is Arduino UNO. The next one is IR sensor to detect the light, and next one is a jumper wise to connection. Next one is batteries. Next one is chassis. This is the basic for the robot arrangement, and this is L293D, and this is caster wheel, and this is HCSR04 ultrasonic sensor, and this is an IC. In this slide, we'll be discussing about the block diagram. We have used one motor shield L293 and two motors, one Arduino UNO and two ultrasonic sensor HCSR04 and two IR sensor, that is SEN00112. So let's see in detail about each component. The first one we will see about motor shield L293D. Here it can drive two motors simultaneously. Motor are arranged in H fashion. H bridge, it is an electronic circuit which enable a voltage to be applied across a load in either direction. It allows a circuit full control over a standard electric DC motor. Now let's see about ultrasonic sensor. Ultrasonic sensor is a device which can measure the distance of an object by using sound wave. It will measure the distance by sending out a sound wave at a particular frequency and listening that when it is bounced back. Next we will see about IR sensors used. Basically IR sensor consists of IR LED and IR photodiodes. The IR LED is called photoemitter and IR diode is called photoreceiver. The IR light emitted by LED strikes the surface and gets reflected back to the photodiode. Now we will see about motor used. A voltage regulator is an electrical regulator designed to automatically maintain a constant voltage level. It converts a positive voltage of which range from 7 to 29 volts to plus 5 volts. So this is the system architecture. Here we have connected to DC motor to the M1 and M2 of Arduino UNO, and we have connected L293D DC motor driver shield, and here we have connected to ultrasonic sensor, and here we have connected to IR sensors. And this is the system flow chart. Here first we will give the command start. If both the sensors are back, if it is S command, then it will be in reverse. If it is no, it will go to does only the left sensor see back. If it is S, it will turn left. Else if it is not S, does only the right sensor see back. If it is S, it turns right. If it is no, it moves forward. This is the line following principle. Here if left sensor, right sensor and black line is detected by the motor, then it moves forward. If it detects any obstacle, the motor will stop immediately using ultrasonic sensor for the obstacle, which is inserted here. If it sees any edge, also it stop immediately, which uses ultrasonic sensor for the edge detection, which will be inserted here. This is the path followed by the robot. Here we follow certain criteria for the path followed by the robot. Here first is the contrasting color or material. The path is usually marked with a contrasting color or material such as black tape on a light colored surface or vice versa. This creates a clear visual distinction between the path and its surrounding and making it easier for the robot sensor to detect. The next one is the sensor. That is, line following robot are equipped with sensors such as IR sensor or color sensor that can detect the contrast between the path and the surrounding surface. These sensors emit light and measure the intensity of the reflected light to determine whether the robot is on the path or off it. The next is the control system. The robot control system processes the sensor data to determine the robot's position relative to the path. If the sensor detects the robot is veering off the path, the control system sends signal to the robot's motor to adjust its direction and bringing it back onto the path. Next one is the PID algorithm, that is proportional integral derivative algorithm to control their movements. That is, this algorithm calculates the error between the desired position of the path and the robot's actual position and then adjusts the robot's speed and direction accordingly. The next one is the feedback loop. The process of detecting the path, processing sensor data and adjusting the robot's movement is continuous, creating a feedback loop that allows the robot to dynamically respond to change in the path and maintain the accurate tracking. And these are the some of the advantages of by UNO robot: easy programming, affordability and community support. Disadvantages are limited processing power, fixed hardware configuration of the UNO board, and dependency on Arduino ecosystem. Here, here are the some of the application where we can use the UNO robot. The line follow robot can be used to deliver foods to the customers in restaurant. In this way, the waiter can no longer prepare food, just enter phone number into the booth and then it will take to the customer. The next one is for the patients, especially those infected with the virus. There is always a risk that they will be infected as the first person, but if it is also very important to give them the medicine on time. In this case, the following robot may be useful. It can easily deliver the medicine. The next, the line follow robot can be used in commercial or manufacturing facilities to move packages or products from one location to the another location using the crane. This is where the robot's edge mechanism is installed. And this is the result. This work is all about line follower and obstacle and edge detection robot using Arduino, which will follow specific line or route and avoid the obstacle and edge in encounters. By attaching the Bluetooth module and a camera, this project can be expanded in the future. This line following and obstacle and edge detection robot can be used as carrying load to transport the goods smoothly and without damage from one position to another. So overall conclusion of this project is the role of the robotics in both global economy and everyday life is undeniably significant, shaping various industries and enhancing efficiency across diverse sectors. The robotics technology market is experiencing a notable upswing, finding applications in manufacturing, medical, utility, defense, and customer industries. The robot's capacity to replace skilled human labor not only increases operational efficiency but also enhances productivity by handling tasks with greater accuracy and at lower cost. So these are the some of the reference I have been used for my project. So thank you all for watching my video. Please do like the video, share and subscribe to my channel. Thank you all.